The next lesson is on graphing linear equations, and graphing linear equations is a very important part of understanding of algebra. But before we can graph, let's talk about what the graph means. In a second here we'll get to this example, but let's just look at 4x plus y equals 8. If we're going to talk about the solution of this linear equation, okay, it's going to be the ordered pair x and y. Again, when we talk about, there's not a coincidence that we always use x's and y's, okay? When we're talking about a solution to this equation, we need an x value and a y value that makes it true. So when we're talking about the graph of a linear equation, and this actually is the solution graph to 4x plus y equals 8. All the points that lie in this blue line here are all the solutions to x plus y. There's all these dots here, and at any of these points you could plug that x value and that y value in, and it would make this side equal this side. So the graph of a linear equation represents all the solutions to that equation. So now let's look at it. It says use the graph to decide whether the point lies on the graph of 4x plus y equals 8. Justify your answer algebraically. So let's take a look at this point 1, 4. Remember, this is our x value, this is our y value. There's an x-axis, a y-axis. Again, this is all related. So the point 1, 4 would be right here. Here's 1, here's 4. Notice that this point lies on this line. Therefore, we could say, yes, this is a solution. Now, to justify it algebraically, what that means is if we plug in this x value and this y value, does this become true? Is 4 times 1 plus 4 equal to equal to 8? 4 plus 4, does that equal 8? Yes, it does. So this is what it means by justified algebraically. Let's look at this next point here, 3.4. So the point 3, 4. If we follow our x value, our x coordinate here to 3, and up to 4, notice it has nothing to do with the graphs of our solutions. Okay, so again, this is the y coordinate here. So you can see that since this point doesn't lie on the graph, the answer is no. And if we were to justify it algebraically, we'd plug in this x value, 3 for x and 4 for y, and we'd say, does 4 times 3 plus 4, does that equal 8? Well, 4 times 3 is 12. 12 plus 4 is 16, and 16 does not equal 8. So you can see it graphically. You can also see it algebraically why these points are solutions or are not solutions. So some of your homework will be just to saying yes, this is a solution, or no, it's not. And some of it you will actually have to graph. Now it says use a table of values to graph the equation 5x equals y minus 2. So we're going to be creating a table. Now, we've already learned how to write things in function form. Basically how to solve for y. So let's take our 5x equal to y minus 2, and let's solve that for y. Okay, and I'm going to tell you why in a second that's actually a smart thing to do. If I want to solve for y, I want to get rid of this 2. It's minus 2, so I'm going to get rid of it by adding 2 to each side. To this side and to this side. Okay, this should be review. We've done this already. These are not like terms, so I just leave it as 5x plus 2 equals y, and these cancel out. And I'm just going to flip it over here and write y equals 5x plus 2. Now the reason we want to do that is so we can create an input-output table to come up with a bunch of solution points. Now when I pick x values, I don't have to go through the work of solving the equation every single time. Here's what I mean. Notice in this case it does not give us any x values. When you're not given any x values, pick whatever you want. My rule is that you have to pick at least 3. You can pick more, but I do not want you to pick less because you need 2 points to make a line. So the third point's your check to make sure you did it right. And I always try to pick at least one negative, and I usually use 0 because that's pretty easy. So I'm going to select some x values, -2. So I'm going to plug a -2 in here. I'm going to go 5 times -2 plus 2. Now, 5 times a -2 is -10. -10 plus 2 equals 8. So my y value is 8. That's going to be the point, if I make my x, y table here, the point -2, 8. Our input's a -2, our output's a 8. Our independent value independent value is -2. We plug that in, y ends up being 8. So now we can plot this point. And of course, I did not pick a big enough graph. Let me try one more. I'm sorry about that. Let's try -1. If I go 5 times -1 plus 2, 5 times a -1 is -5, plus 2 is a -3. So I get the point -1, -3. -1, -3 would be right here. Now I could have done -2, -8. It would just fallen down here and I can't go any further. Okay. So now I'm going to try 0. Again, I like to try a negative and I like to do 0 because 0 usually makes a number go away. 5 times 0 is 0 plus 2. That ends up being 2. So we have the point 0, 2. 0 means we don't move left or right at all, and then we just go up 2. And now let's try one more. If I put a 1 in, I'm going to go 5 times 1 plus 2. 5 times 1 is 5, plus 2 is 7. We get the point 1, 7. So I plot the point 1, 7. I end up right here. Now if you notice, these 3 points all lie on a line. And when we graph linear equations, just like the one I originally showed you, you do draw a line on them. And you draw a line and you have arrows at both ends. And the reason is because, remember, every single point on this line is a solution. If I had done -2 to -8, that would have been right here. That would be on the line. Okay? So you could pick any of these points. Now it's a little more difficult. Oops. It's a little more difficult because we can't see what the points are unless they cross at the grid lines. But you want to draw a line through it, and that line represents all the solutions. So I apologize again. Okay, so this is a solution, this is a solution, this is a solution. Everything on this line is a solution. Okay. So this line, that's why we draw a line through it and draw arrows at both ends. There's an arrow there. Now, the reason it was easier to solve for y first is because if you didn't, and we wanted to put a -2 in, our original equation right here, I would have had to go 5 times a -2 equals y minus 2. And then I would have said 5 times a -2 is -10, which equals y minus 2. And then I would have had to add 2 every single time. Now, I'd come up with the same answer. I'm sorry, that's not right. -8. I would have come up with the same answer, but I had to go through a lot more work, and I would have to do it every single time. Do the work up front, solve for y, and then plugging in the numbers becomes really easy. So, when we look at this, remember our goal, put it in function form, meaning solve for y. Pick some x values, pick whatever you want, but I would keep the numbers kind of small. Try both positive and negative. Make sure you try 3 numbers. And when you graph your points, make sure they all lie in a line. If one's out here, you made a mistake somewhere. Okay? Draw your line and make sure you include arrows at the end to represent all the solutions to that linear equation.